Graphing using transformations, part 4. Use transformations of the graph of f of x equals x squared to determine the graph of the given function. H of x equals negative x plus 2 squared. First, we need to know what the graph of f of x equals x squared looks like. And this is a common graph, and a picture of this is found in your textbook. And this is a basic parabola, or a U-shaped graph. If we didn't know what the shape of this graph looked like, then we could just plug values in for x and solve for y to find an ordered pair. So that's what I did in this chart. I just took values for x, which is negative 2, negative 1, 0, 1, and 2, and then I plugged them in for x in the equation f of x equals x squared, and then I found my y coordinate. So I got these 5 ordered pairs: negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. And we'll just plot these ordered pairs. So we have a negative 2, 4, and then a negative 1, 1, 0, 0, 1, 1, and 2, 4. And it makes a U shape. So this is our basic graph f of x equals x squared. And we want to apply transformations to graph h of x. Now the negative that's being applied to the entire function tells me that I'm going to reflect it about the x-axis. That tells me that my y values will change to the opposite sign. In other words, my entire U-shaped graph or parabola is going to reflect about the x-axis, so it's going to turn over. Instead of opening up, it's going to open down. The plus 2 within parentheses tells me that I'm going to go to the left 2 units. That's because the plus 2 is on the inside of the function. Do you see how the plus 2 is also being squared? So this whole parenthesis is really the x, and so it's within the f of x function. It's within the parentheses. So that means that I'm going to have a horizontal movement of right or left, and since it's plus, you do the opposite, which is move left instead of right. So I'm going to move left 2 units, and moving left is going to affect my x values. Okay, so here I wrote down all of the ordered pairs that are in my original parabola. Then I started writing my new x values. So we said that we're going to move left 2 units, so that means I'm going to subtract 2 from my x value of my original ordered pair. So here in each of the x value position, I just took my original x value and then subtracted 2 from it. Now I'm going to find my new y values, and I'm going to take the opposite of the y values. So I'm going to take the negative of the original y values, so this is just a negative 0, which would just be 0, and then a negative 1 here, another negative 1, a negative 4, and then another negative 4. And now I can clean up each of these ordered pairs by performing the calculations within the x and y value position. So when we do that, we have a 0 minus 2, which is a negative 2, and then a 0 for my y. Minus 1, a negative 1 minus 2 is a negative 3, and that will be a negative 1 for my y. And then 1 minus 2 is a negative 1, and also a negative 1 for my y. And then a negative 2 minus 2 gives me a negative 4 with a negative 4. And then 2 minus 2 is 0 with a negative 4. So these blue ordered pairs represent my new ordered pairs of my transformed function, which is h of x. So I'm just going to plot these new ordered pairs. I have negative 2, 0, negative 3, negative 1, negative 1, negative 1, negative 4, negative 4, and 0, negative 4. And then I'll connect the dots to have a U shape. And this is my new parabola. And as you can see, each point was reflected, so the parabola flipped over across the x-axis, and then they each moved 2 places to the left. And that blue graph is my final answer.